The star Betelgeuse, a red, extremely huge beast found in the sublime group of Orion, has long enchanted stargazers and cosmologists alike due to its sheer size and splendor. If Betelgeuse were placed where our Sun is, it would stretch out to the orbit of Jupiter, certifying its titanic size. Despite being located around 642 light-years from Earth, its massive size makes it one of the brightest stars visible to the naked eye. Recently, Betelgeuse has exhibited peculiar behavior, such as dramatic dimming and brightening cycles, which many experts believe signal that the star is nearing the end of its life. The renowned physicist Brian Cox recently stated that Betelgeuse is on the verge of a catastrophic explosion expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life but will provide a dramatic opportunity for researchers to study one of the most astonishing and powerful phenomena in the universe. As a red supergiant, Betelgeuse is one of the largest and most massive types of stars. It has been on astronomers' radar for decades, but its recent unusual fluctuations in brightness have sparked speculation that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering a massive explosion that releases an enormous amount of energy, radiation, and material into space. Betelgeuse's impending explosion is expected to be a Type II supernova, a specific type of stellar blast that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it could be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would typically be catastrophic if it occurred near Earth, Betelgeuse's distance of approximately 642 light-years ensures that, although the explosion will be spectacular and dramatic, it poses no threat to life on our planet. Nonetheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in minutes than the Sun will generate over its entire lifetime. Betelgeuse's explosion won't just be an extraordinary cosmic display but also a significant moment for science. Researchers are eager to observe this fascinating event from its earliest stages, using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most critical aspects of the supernova will be the burst of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion, as they can pass through nearly everything unimpeded. Observatories such as Japan's Superkamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in monitoring Betelgeuse's final moments. The explosion will also provide vital insights into the creation of heavy elements. When stars explode, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give researchers a clearer understanding of this element formation process, crucial for comprehending planetary formation and the chemistry of the universe. While Betelgeuse's supernova is not expected to have a catastrophic impact on Earth, it will interact with our planet's atmosphere and magnetic field in captivating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could intensify auroras, expanding the regions where the northern and southern lights are visible. Although these cosmic rays might affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and temporary. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will not only fascinate scientists but also amateur stargazers and the general public, sparking renewed interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds urgency to the matter. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be crucial, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the scale of the universe. The event will also provide a rare chance to study dark matter and its potential influence on the structure of the universe. Dark matter, the mysterious substance that makes up around 85% of the universe's mass, neither emits nor absorbs light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the large-scale structure of the universe. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living beings. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The cultural significance of Betelgeuse's explosion is also profound. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such celestial events have been interpreted as omens or signs of great change. Betelgeuse's explosion may inspire a mix of awe, wonder, and introspection as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the cosmos. Cosmologists are, as of now, preparing for the occasion, as modern technology allows almost anyone with a camera or telescope to observe and record the cosmic explosion. This democratization of science will unite people across the globe, all watching and recording the same massive phenomenon from their unique vantage points. Betelgeuse's blast isn't just a spectacular cosmic event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humankind looks to extend its presence in the solar system and beyond. Moreover, the blast will reignite interest in the search for extraterrestrial life. Supernovae are essential for spreading the elements needed for life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how the building blocks of life could spread to other planetary systems and possibly spark life elsewhere in the universe. The imminent explosion of Betelgeuse is set to be one of the most significant cosmic events in recent memory. Its supernova will provide a wealth of scientific data, enhancing our understanding of the universe and undoubtedly dazzling people around the world. Betelgeuse's death will mark the end of a giant star, but it will also represent the ongoing cycle of creation and destruction that governs the universe. It reminds us that, from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces erupts into view. For both scientists and stargazers alike, Betelgeuse's final phase offers profound opportunities. One of the more speculative yet fascinating possibilities linked to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These enigmatic forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae, like the one expected from Betelgeuse, could hold the key to unlocking some of these mysteries. Supernovae release vast amounts of energy and radiation, and some researchers believe these powerful forces might interact with dark matter in observable ways. One intriguing hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy produced by Betelgeuse's supernova could provide clues to their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, a phenomenon that has puzzled scientists for decades. Additionally, there is potential for Betelgeuse's explosion to offer insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the greatest challenges in modern physics. Betelgeuse's blast could provide indirect evidence of dark energy's influence on stellar death. As supernovae are thought to be affected by the universe's expansion, any data that sheds light on this topic would be revolutionary. Betelgeuse's impending supernova is more than just a spectacular celestial event. It holds the potential to offer critical insights into some of the greatest unanswered questions about the universe, including the nature of dark matter and dark energy. Its explosion will be a powerful reminder of the ever-evolving nature of the cosmos, fueling the curiosity of scientists and stargazers alike. As researchers prepare for Betelgeuse's potential supernova, the event offers an unparalleled opportunity to test and refine existing theories in astronomy. One significant aspect is how the explosion will help astronomers improve models of stellar evolution. The transformation of massive stars into supernovae has long been a subject of study, yet the exact mechanisms and variations in this process remain unclear. Betelgeuse, as a nearby red supergiant, will allow researchers to study the star's final moments in detail, providing data on the fusion processes in its core, the dynamics of its outer layers, and the shock wave generated during the collapse. This will enable scientists to refine our understanding of how stars of this size and type evolve and explode. Furthermore, the supernova could enhance our knowledge of neutrinos, key particles that pass through matter with almost no interaction. Detecting these particles from a supernova provides a direct way to study stellar core processes that are otherwise invisible. For decades, scientists have struggled to capture these elusive particles, and the neutrino burst expected from Betelgeuse will offer a unique opportunity to track the behavior of these particles as they traverse space and interact with detectors on Earth. The explosion will also have significant implications for the study of gravitational waves. While black holes and neutron stars are often the primary sources of gravitational wave research, the collapse of Betelgeuse may generate waves detectable by observatories like LIGO, Laser Interferometer Gravitational Wave Observatory. These waves could provide further insight into the physics of massive stellar collapses and possibly even reveal new details about the structure of spacetime itself. Detecting gravitational waves from a supernova would mark a critical milestone in the emerging field of multi-messenger astronomy, where signals from different forms of radiation, such as light, neutrinos, and gravitational waves, are combined to provide a more comprehensive understanding of stellar events. In addition to these scientific advancements, Betelgeuse's supernova could also inspire future space exploration missions. Understanding the remnants of a supernova, particularly the neutron stars and black holes that often result from such events, is crucial for planning deep space missions. As humanity looks toward venturing beyond our solar system, understanding how these extreme environments form and behave could aid in navigating and preparing for future interstellar travel. Beyond the scientific world, the explosion of Betelgeuse holds cultural significance. The event will ignite conversations about the life and death of stars, the vastness of the universe, and humanity's place within it. People around the world will marvel at the spectacle in the night sky, a tangible reminder of the impermanence of everything around us. This shared experience could foster a renewed sense of wonder and curiosity about the universe, inspiring people to engage with astronomy and the natural world in meaningful ways. Ultimately, as scientists continue to observe Betelgeuse's changes and prepare for the supernova, it serves as a reminder of the unpredictable and dynamic nature of the universe. While we have mapped out many cosmic phenomena, there is still much we do not understand. Betelgeuse's explosion will contribute to a growing body of knowledge, sparking further exploration and inspiring the next generation of astronomers, physicists, and space explorers. Betelgeuse's imminent supernova is also an opportunity to explore how cosmic events affect the interstellar medium, the gas and dust that exists between stars. The shock wave from a supernova can drastically influence this medium, triggering the formation of new stars or altering the structure of existing ones. By observing the interaction between Betelgeuse's explosion and the surrounding space, astronomers will gain insight into how these interstellar materials are shaped and enriched over time. This process plays a critical role in the life cycle of galaxies, contributing to star formation and the overall evolution of the universe. Additionally, Betelgeuse's supernova will offer a rare chance to study the rapid changes in light and radiation as it undergoes its final moments. Researchers will closely monitor the bursts of gamma rays, X-rays, and ultraviolet radiation emitted during the explosion. These emissions will reveal crucial information about the star's internal structure, temperature, and the dynamics of the explosion itself. Understanding the precise mechanics of these cataclysmic events will help refine models of star death and offer clues about the end stages of massive stars throughout the universe. In essence, Betelgeuse's death is not just a cosmic spectacle but a vital piece of the puzzle in understanding the universe's ongoing cycle of creation and destruction.